So we just connected to that section. Yes, ma'am, it is streaming. It is true. We'll send you the link.
It's my pleasure to welcome you all to the second day of Actually Developing program on emerging trends in quantum computing and AI for academia and research, jointly organized by Circuits Cluster Branch in association with IEEE and IPAD, DAYANANDA College of Engineering, Bangalore. It's my immense pleasure to welcome Ms. Mrinalini Barrett, Senior Application Engineer, Digital Technologies Private Limited, on behalf of management of DSI, Department of ECE, EIE, ETE, and Physics, I welcome you, ma'am. I request Mr. Joseph, Dr. Joseph, sir, to hand over a book as a token of respect. Please. Ms. Mrinalini Bharat is currently working with Digital Technologies Private Limited as a senior application engineer. She has completed her master's in wireless communication from VIT, Misra. Mrinalini is focused on bringing advanced AI-driven image processing and analysis tools to academic institutions. She collaborated closely with the colleges to integrate vision AI projects into their engineering programs, providing students with practical experience in fields like robotics and smart surveillances. On behalf of all, I welcome you, ma'am. I request Mrinalini ma'am to take over the session. Please.
Okay. Good afternoon, everyone. And I am Mrinalini Bare. So I am working in Digital since 5 years. So I am like first doing a role of application engineer for giving trainings, workshops, seminars, developing solutions. Now currently working as an application engineer and a developer. So in developing part, I am currently working with Vision AI applications. So developing solutions on vision board, like IoT, all these technologies which are very trending these days. So I'm working on that. And today we will start the session with I have a small presentation where we will be talking about what is AI, what is the workflow of building an AI model. Then we will be working, I will be showing a demonstration how you can build your own AI ML model and deploy it inside the microcontroller board. So this is the agenda for this um, 3 hours. And so we will make this session as an interactive session. So if you have any questions, any queries, you can please raise your hand. I can ask. And if you want, at the end of the session, if you want any solution for your ongoing paperwork or any project works, you can also tell me and we can discuss for the same. So before starting with the presentation, can I know what is the understanding of AI among yourselves? Like, what do you think? What is AI? Any answers?
Like voice commands and data searching, pattern searching,
Yes.
web scraping.
Yes. So this sir told very good examples of AI. Like now recently, like if you talk about 2 3 years, we have got Chat GPT. Okay, is an example of AI? Yes or no? Yes, because Chat GPT, like how Chat GPT works basically, like it's an Okay, can anyone tell me what is difference between Google and ChatGPT? Like Google is there, then Google is also for searching something. Okay, ChatGPT is also where we can give our questions and it gives the answer. So, what is the major difference between your Google command and your ChatGPT?
Google will directly take us to certain links that is available. But in case of ChatGPT, it will summarize the information, right? Okay. And it will give every time you
Partially correct, but one of the main differences in ChatGPT, we give a prompt. Okay, like I want a summarized way of some AI technologies emerging in industry, something like that. Okay, it will give you a paragraph. Okay, but no, this paragraph I didn't like. I'm giving feedback to it. In Google, you can't give a feedback. It's just I need some pictures of Vision AI. It will give you, but you can't give like no. I don't want these kind of pictures. I want something else. So that thing is only possible in ChatGPT. So this is the major difference between ChatGPT and Google command. So now there are so many day-to-day applications available for the AI. Like we have smart washing machines, we have smart televisions, we have smart this air conditioning. So all these are smart AIs. So usually when we talk about like 10 years or 12 years back, we have normal digital watches, okay? But now we have smart watches instead of digital. Like we have digital, but we are having smart watches also. So these smart watches basically gives you your health check, like it gives your health criterias, how many steps you have walked, how many, what is your heart rate, what is your like the speed and all. So everything it gives, okay? It summarize your health and like about your body. But in digital, we have only a certain thing where we can see the time and that's it, okay? So in a normal watch, in a normal device, we have implemented AI, okay? So when your heart rate goes down, a notification will come that your heart rate is low, your BP is low, you can have some medicines or something. So that is your AI implementation on a small device, on a normal device. So when AI technology is being implemented to a normal device, it becomes edge AI device. Okay, so AI is implemented in a edge. Edge means your device. Okay. So now when you must have heard about edge AI, embedded AI, all these things. So this thing in our lab setup or in our academics part, we talk about microcontrollers. Okay. So here where like we can implement AI in microcontrollers, that is your edge AI device. So um, now I will just start with the okay. So coming to the AI, how it is like what is the basic definition of AI? So AI in a simple term is it acts as a human brain, okay? It acts as a human brain, and the works which a human can do, it performs, but without a human interference. So that is your basic definition of AI, where it acts as a human, but it is not properly to humans. Like it can't do a like more proper or more accurate jobs. But without human interference, you can perform like some works or some certain assignments you can work. So nowadays in world or in research, there are robots, human robots being created. So I think if we see that in 10 years, we will be having robots moving here and there, like which can give you medicines, which can give you, like in some restaurant I've seen, robots are serving the food. So this technology can really overshadow humans, I think. And but there is an disadvantage also to this technology because human are like the thinking power is becoming little low because if you see students earlier we used to do our assignments, we used to sit in nights and we have to complete the assignment thinking by own we should like we were I was reading articles this that and then doing my assignment, but nowadays students just give a prompt in ChatGPT and they get the whole solution. So somewhere it's a disadvantage to the society, but yes, our India is growing, our technology is growing, and this is how you can we can develop your our own solutions, AI things, and there are so many AI startups which create every year they create a small device which can be for healthcare industry or which can be for used for agriculture industry. So these are some certain major industries which can AI can be focused on. Okay. So earlier we were working on C++ programming, but when we were working on C++ programming, if you have worked on Turbo C++, so in Turbo C++, you were writing the code in C++ programming, and you were just printing the statement, and you will get the output in console, the panel or console panel, anything. Can you use that output to some microcontroller or to put it in some microprocessor anywhere? No, because there is no only the output, the raw data you can't implement in a or deploy in a microcontroller. So for this, we have machine learning technology. So in this machine learning, is it? Then you have Windows. Yes, ma'am, we duplicated it. Yes, ma'am. Projector to screen. Do we have a remote? I'll call. So I was talking about the standard programs and the machine learning. So in standard programming is basically for C and C++ programming. So in C++ programming, we were only giving a input printing statement and we were getting the output, like sum of two numbers, Fibonacci series, something like that. But when ML came, when machine learning came to this industry, we can build the machine learning model, we can train a machine according to our desired output, and we can get the certain output, and we can also deploy that machine learning to a microcontroller. So there is where you can implement your AI ML thing to full microcontroller. Like how, can anyone tell how machine learning works? What is the first step of machine learning? Building a machine learning model. Training. Before training, gathering the data. Yes. So data collection is the first step. Okay. So if you are building any AI ML model, the first step is to build it. Sorry. First step is to collect the data. Okay. So if you're working with sensors, you have to first collect the sensor data. Okay. Then after collecting the sensor data, you will be moving to the processing of that sensor data. The step is known as image processing. If you're working with images, cleaning of data, lights. It's fine. Yes, exactly. Yeah, Yes. So, I was talking about the process of AI ML model. So, first part will be your data collection. Then we will move to the data processing, pre-processing step, where you have to clean the data. So after that, these two steps are very important if you're building your AI ML model. Then comes your building your machine learning model, the model building part. So in machine learning model, everyone has worked with any of like one or more algorithms like YOLO model or some CNN model, neural networks, all these models you must have worked on, okay? So this is how you can build your algorithm choosing any of the machine learning algorithms. You can build your machine learning for anything like predictive things or classification things, detection of things. So all these things you can do it. But now your machine learning part is completed. You have built your machine learning part, but your data, like you're getting the output in your desktop, like in your laptop, in your computer. But now, if you want to make it has a product, it has a standalone model, then you should dump it inside the microcontroller. So that is the final and end step where you deploy your machine learning model to a microcontroller board. It can be any kind of microcontroller boards like firstly, we had Arduino Uno, but Arduino Uno didn't have the capabilities of dumping a AI model, AI machine learning model. If then we came with ESP32. In ESP32, we can dump the models, AI models, like the machine learning models, but we need to go for the third party. Like we have to go for the MicroPython, we have to code it there, then we have to dump it. We have Raspberry Pis also, but now everyone will be thinking we can use it in Arduino, Raspberry Pi, and the six. But do you know that Raspberry Pi really consumes high power? Raspberry Pi, if NVIDIA, Jetson Nano, all these boards really consume high power, but compared to this power consumption, the STM board is very less power consumption. Okay, so like it's in very low power consumption. If you go and search back while you're going home, you can search back and you can see that STM microcontroller boards are very like they use really low power. Okay, so this is how this workflow happens. But now I will tell you about the standard programming and machine learning part. So here basically we have an input data. We have given A and B. Then we set a rule that sum of two numbers, okay, and it will give you the okay. But we can't use this output in a microcontroller or any other hardware. But here in machine learning, we have input data, we we set a desired output. Like I want this machine to recognize few faces. It should count how many people are present in this auditorium. So this is how I give the input, and then it will give you the output based on your set rules. Okay, so this is how machine learning works. So machine learning is where you are training a machine to do a certain or do a desired like give your desired output. Okay, clear till now? Yes. So now, what is an AI approach? Okay, so in this AI approach, we have data center cloud, we have edge nodes, we have edge things. So I have told you about edge. Okay, what is edge? Now, have you heard about cloud? Everyone must have heard about cloud. Okay, IoT platform, cloud platforms, all these things. So cloud platform is basically where you will be storing the data. Okay, data in the outputs, data, you can visualize it, you can analyze it. That is your storage part. Okay. So in AI also, if you want to connect to an IoT part, that is an extension of normal microcontroller AI ML model. So first thing comes as data center cloud, where you can analyze, store, and visualize. So here we have thousands of data center cloud. Then we come to edge nodes. Edge nodes basically are the gateways where there are devices and it sends a gateway where it sends the data. So edge nodes where IoT gateways, micro data centers, where this is in bridge where it takes the data and sends to the cloud. Okay, and then we have billions of edge things. So in this, like I gave an example in starting, a smart watch. Okay, a normal watch when AI approach is taken, it becomes a smart device, a smart edge. Okay, so we have coffee machines, we have drilling machines, we have drones, we have washing machines, pump, camera surveillance system, ACs. All these things are edge things. But when AI is implemented, it becomes smart devices because a normal device is converted to a smart device because it's giving you a certain outputs, okay, certain outputs which can be like you can remotely access it or you can store it, you can do any kind of visualization from your outputs. Talking about the advantage or the features, we have ultra low latency. We have it's a more reliable thing. Security of data. If you are building any model, if you are storing the data, it will be secured. It won't be breached. Privacy by design. Your models, your ML models, your AI models won't be like breached, and the privacy will be there. Sustainable on energy, better user experience because when we compare it with Raspberry Pi, it is easier. Like Raspberry Pi is also easier because there are solutions available in your computer, like in your Google. But when we are integrating the Raspberry Pi board, we need a operating system. We have to dump a operating system. We have to give an SD card, then connect a monitor, connect a camera, connect the keyboards, mouse, everything. So it is a high cost and also a very complex procedure. Okay, but when we have our microcontroller boards of C, it is like just plug the board, build the model, dump the model. That's it. You can see your outputs in display or any. You can see the outputs in your IoT platform. Anywhere. So this is how it is a better user experience. Now, what are the applications or real life applications, examples of AI? So first we have home maintenance. In home maintenance, there are so many applications, but one of this example is a dishwasher. We have smart dishwashers nowadays in home where you can just give your dishes. You can set the temperature of hot water or cold water, like how much amount you want to give your liquids, everything. Okay, it will wash it, it will dry it, and it will give you final thing. Okay, but here, if your dishwasher is not working properly, it is making some sound or it is not giving you the hot water. So this is how your AI like plays a role because I will be like if this is not a smart dishwasher, it's a normal dishwasher. I'm not getting the hot water. I have to go there. I have to check it. What is the problem? Have to call the electrician. He has to check it. Then it will take a long process. Okay, but I am not in my room. Like I am traveling somewhere, and I get a notification that my dishwasher is not working. It is not giving a hot water or something, some kind of notification you're getting or some kind of alert systems you're getting. Okay, so this is how AI process is implemented in your dishwasher that it gives your certain alert systems or some certain outputs. Okay, so this is the basic, a small example from home maintenance. We have industrial maintenance. In industrial maintenance, like in big factories, machineries, you must have seen so many machineries are there. Okay? Like if you go to a paper factory, there will be so many big machineries. Okay, big machineries will be there. But if one machine gets that, like it is not working properly or it is getting heat up, so the owner has to send the employee, he has to check it. Something can happen also. But to reduce that process, the owner can get the notification that your machinery is giving an abnormal signal. Okay, it's giving some kind of like abnormal signal or anomaly signal, some kind of abnormalities are there. Okay, so it can get reduced or it can get corrected also. So this is how in industry you can use for predictive maintenance, for monitoring of health of the machine. All these things can be done in industrial maintenance. Then we have security, like you're not in home and someone in night like jumps inside your home and suddenly the glass breaks down. Okay, so based on that breaking sound, the glass breaking sound, you will get the notification that someone has entered your house. Because like when we do, like in our training sessions also, we give an project of audio classification. So in that, basically we make the students collect different kind of signals. Like we can take an ambulance signal, sorry, ambulance sound. We can take a normal surrounding noise, a baby cry noise, all these things. So it gets classified based on that. Like at last we will be getting, this is the classification for baby cry sound, this is the classification for ambulance. So all these things we can do it. So say you can do this project like glass breaking sound, you can do it. So based on the door sound, you can do a smart surveillance system. Like all, there are so many possibilities of building a application, AI application. Then last, we have people counting. This is very common, like in restaurants and all. They have applied this people counting system, and based on that, it gives you a waiting time. Like I have booked a table for 8 o'clock, but people are standing before me. So I have like, if I go there, I have to wait for 10-15 minutes. So I get a notification that sorry, you can come after 10 minutes because your table is not vacant yet. So that is of people counting, that how many people are present in a room, how many members are standing, what is the waiting time, all these things can be estimated and told. So, so this is not camera based. This is sensor based only. So based on TOF sensor, you can use it. This people counting system is without the camera. With camera, you can have go for the vision AI application. This is just an AI application, like HAI application, which is very basic microcontroller mode. So now you will be thinking that how we can develop a machine learning model in this small microcontroller mode. Okay, so how we can develop a machine learning model in this small, this look like an Arduino Uno, but features are more better than Arduino Uno, and most of the like very important thing that it is a industry use microcontroller mode. Arduino Uno you have been seeing or working on it, but Arduino Uno thing is not used in an industry anywhere. Okay, like I have taken so many interviews for students, all these things. So they have done projects in Arduino, okay, Arduino, Raspberry Pi, but some students from their college, they have worked on other microcontrollers. So obviously we select them because we know Arduino Uno solutions are available. Anyone can build a solution on Arduino Uno, but student who has gone to many other, like who has worked with the microcontrollers, other kind of microcontrollers, we give them the chance because yes, they have the capability of learning and they have interest. How like they really like they develop good solutions on that. So we see that. So based on Arduino and all, people like usually reject students. So I always recommend that students should work on different, they should explore more of microcontrollers. They shouldn't be just attached to Arduino Uno. So you can also insist your students, your department students, to work on these kind of microcontroller boards, because it really makes a good resume. The students can present to the recruiters also, okay? Because they see that what all microcontrollers you have worked on. If it's in a core company, if it's a sector company, they will not see. They will just see what is your coding performance, this that. They will select basis on the thing. But being an EC circuit student, circuit department students should go to the core companies. Because of money and high salary and all, they shift to the IT sectors. But this is the main focus. They should focus on the core companies. And so this was the idea, like buying this microcontroller and all. So this in this microcontroller, how we can build our AI/ML models. So we have two processes. I will explain the first process, then I will move to the second step. So the first process is using Nano Edge AI Studio. This is an software which builds your automatic machine learning model. Okay, just you have to give the data and it will build you the machine learning model, because it has pre-built or pre-trained models like SVM, RF, ZSM, NLP, MML. So all these models are already there in this NanoAGI software. Okay, so based on your data, based on your training, it gives you a best model, and this is how you can build your machine learning model. Fine.
Is it open source?
Yes, it's open source, but it is based on the license. So you have for colleges and all, usually they take for educational license, and if you want to use as a personal use, you can register it and you will get a license key, and you can use that license key and perform all AI models in this software. So this is very simple. Like if you don't have a knowledge of machine learning also, you can build your machine learning models in this NanoAGI. So here in NanoAGI, it nearly gives you an accuracy of 100%, like 99.9%. Like how you're training a model, that is how the accuracy comes. So it will be near to 100%. But ideally, if you are building the AI models, ideally it should be above 95%, because if it is 85%, your product or your model won't be sent in a market, or it won't be a good output. It won't give a good output. So that's why we usually see for the above, like 95 above percentage of accuracy. Yeah. So this was the first step. Like Nano HAI software was the first step where it will build the ML model. Okay, we don't have to build the ML model, but the second process is using STM32Cube.ai software. It's a package basically. I like most of the people must have worked on CubeID, STM32Cube ID. It's an open source platform for this boards, for all the ST boards. Okay, so that is based on ID platform only, like Arduino ID. But the speciality is that you can configure the pins and generate the code, so that you don't have to write the code fully. You can just write the print statements or some functions. That's it. But from Arduino ID, you have to write the code from the scratch. That is reduced. The work is reduced in this cube ID. So using this cube.ai, if you're building your own machine learning model, like in Google Colab, in Visual Studio Code, or in Jupyter Notebook, you can build your own machine learning model, and you can dump or deploy your machine learning code inside the microcontroller using this STM32Cube.ai. Okay, because can we deploy a direct Python code to the microcontroller board? No. So for converting, we need to first convert the Python model to C++ library. Then we can deploy that C++ library into the microcontroller board. Clear? That conversion. Yeah. So this conversion will happen through AI frameworks. Okay. Like I have built a basic CNN model. Okay. Of different gestures. Okay. Pitch your role gesture. Okay. Now I've saved the model. I've saved the Python model, but I can't just download that model deploy inside my cube.ai. I need to convert it to a Keras or TF-Lite, or if you're working with MATLAB, you have to convert it to ONNX extension. So these TF-Lite, Keras, ONX, scikit-learn, PyTorch, all these are called as AI frameworks. So you have to first convert it to the AI frameworks. Then using that extension, you have to download that model and you can dump it inside the hardware. Okay, so these are the two processes. One is the software will automatically build the model. You have to just give the data. One is if you want to build your machine learning model, you can do in this way. Okay. I will at the end I will tell you one more simpler way for this. So we see that also. Yeah. You told that pre-trained models will be redundant. Can you just change the architecture? That option is in this long programming, you can change the architecture. In Nano AGI, yeah. No, in Nano AGI, you can't change the, yeah, like it has ZSM, it has RF, it has SVM, okay? Based on your data collection and what model you have choose, like there is four kinds of model. One is your anomaly detection, one is your classification, one is your extrapolation, and one is your normal one class signal. So in extrapolation, if you're building a prediction based model, you can go for that. If you're going for detection, like what is normal and what is abnormal, you can go for anomaly. Classification, three signals you have, four signals you have, you want to classify it, that is your N class classification. But these all four categories has its own predefined models present. So based on your data, you will get the best model and the accuracy will be like that only. Like I have trained 500 number of datas, okay? But you have trained 100 number of datas. My model and your model can differ because I have collected more number of datas and you have collected less number of datas, and the accuracy may also be different. So the main part of machine learning, if you're building machine learning model, the data should be more, and you should remember that you're not training your model very like you must have heard about two terms, overfitting and underfitting. So training a model more like in the average of the training cycle, it can be overfitting, and if you're training it less, can be underfitting. Because you're not training it properly, it will not give you an output. So if you're training the model more, that means then also you will not get the accuracy properly. So these are all things you should keep in mind when you're building your machine learning model. So this was the board I was talking about. So this is a basic edge AI board, embedded board, which is based on ARM Cortex M4 processor, and it is a 32-bit microprocessor. This is the chip which is of ARM Cortex 34-bit, and this is also similar to Arduino, like it has Arduino pins also, but the RAM size, the SD RAM, the flash memory, all are better than the Arduino Uno board. And it has a RAM of 1 MB, flash memory of 512 KB. So all these features are there. It has user button. It has LEDs. You can perform any kind of communication protocols like I2C, SPI, USART, analog, can connect any kind of sensors also, collect the sensors, build an AIML model, and deploy that AIML model inside this microcontroller board. So this is how it works. So like you can connect to the channels and you can do the interfacing. So any doubts still here? Clear? Yes. So now I will be just showing you the process. Like from the starting, how you can like what is the first step, how we will be collecting the data, how we will be building the model, and we will be dumping the model inside the hardware. So this is the step, and the objective of this demonstration will be I thought of hands-on, but like just demonstration we can see and we can plan for some hands-on later on. So this is like the objective of this demonstration will be to find or to detect the anomalies. Like I have a fan and I will be moving that fan in a particular speed, okay? But if my fan starts giving an anomaly signal, like some vibration or some external sound, that means it's giving an abnormal signal. Okay, how to detect that? What is normal and what is abnormal? Okay, so that we will be looking. And like for an example, this AC, you must have seen that some ACs make sound or they don't give a cooling, proper cooling, or this make a vibration. So this is how you can predict or detect what is normal signal and what is abnormal signal. So just give me 1 minute, let me set.
Really take a risk.
Baby.
Also,
Yes, development part is free. Yes. And like we take hardware from different OEMs like ST. We are authorized partner of N9, Vigilant, and these also. We basically give solutions, lab setup, we give projects for industries also. So all these solution part is our job. So, the objective will be to detect the anomaly of this fan if it's giving a good vibration, like good signal or a bad signal. So, here I have connected the sensor. So, this sensor is basically a motion sensor, motion or a motion vibration sensor. So, this axis, the total axis of the sensor is 6-axis motion sensor because 3 for accelerometer and 3 for gyroscope. So it has two parts, gyroscope values also it gives and accelerometer values also it gives. So like if you're working with some speed or some vibrations, you can always go for accelerometer. And if you are having a like gestures or detection of gestures, like a classification of gestures, you can go for gyroscope value. So here, like for an example, this is a pump, motor pump. You will be connecting the sensor on top of this pump, collecting the sensor data, then building the model if it's okay or not okay, and then dumping inside the microcontroller board, and then detecting the outputs if it is giving anomaly or normal data. So, talking about the application, we can have operational efficient, like applicational relevance, we can have operational efficiency, product quality, we can check for the security, we can check for the utilization. So, all these parameters we can check. What will be the objective? Like we are using the ST microelectronics technology, the hardware and the software which we are going to use it has Nano Edge AI Studio. So this in that Nano Edge AI, I will tell you how the model has been trained and how you can collect the data and how you can train your model. Okay. So this is the setup, the same setup with the fan, the board, and the sensor on top of the fan. Instead of fan, you can have machineries also. Like recently, we had an training in Triple E department. So in Triple E department, usually I think HOD sir's name is Prem Kumar sir. So sir told that I don't want these normal applications. I want electrical specific applications. So he told that I have specific pumps like the motor pumps, motors and all. So I want you to measure the vibration of these motors and build an AI model. So we send our engineers like to college and they collected the data of different motors, big, smaller to a big motor. Okay. So based on the temperature data, based on the vibrations, based on the speed, all these data they collected and he prepared an AI model and it can predict what is normal when the motor is heated up. All these applications were performed. Last 2 weeks only they were doing the training and recently it got ended. So this is the setup. So I have explained the process, the workflow of the AI ML model. But this is the Edge AI development workflow where we have data preparation, where you can collect the data acquisition, then where after data acquisition there comes data processing, cleaning of data basically. Then second step will be development, where you have to build the model, you have to select the model, train the model, and test the model. Okay, that is done. Then comes your third part where your model implementation is there and you have to deploy that machine learning model inside the microcontroller board to make it has a standalone model. You can just give an external power supply and attach it in this AC and you can check whether it's giving abnormal and normal signal. So this is how end-to-end AI project you can build. So here, talking about the anomaly workflow, on the PC side, we will open the NanoHAI software, we will collect the data, we will build the model, and we'll get the ML library. Here we get the ML library, and then on the MCU part, we will dump that library, like we'll code it, we'll dump that. So that means it gives what is normal the output. So outcome will be, it will detect the anomalies in real time, predictive maintenance of any kind of machineries you can perform. And also, if you want to do the cloud connectivity, you can have Adafruit, you can work with ThinkSpeak, AWS, or Blink app. All these IoT platforms you can work on, and you can transfer the data on the IoT platform. But this microcontroller is not capable of Wi-Fi initialization because Wi-Fi module is not present. If you want to go for IoT AI part, you can have a different ST board which is available, IoT AIoT board. So in that you can perform AI models and you can also transfer your data to IoT cloud platforms. So use cases, industrial machinery monitoring, motor fault detection, pump performance, equipment monitoring, health monitoring of different big machineries. So anomaly for predictive maintenance, like I told, machine will be here. Then we can log the sensor, like we can create the data logger code and we can collect the data. Then we can build a machine learning model and then it can find the like it can give you an output and we can send it up a cloud platform also. So this is a full process of building an AI ML model only, or you can extend it to the IoT part also. Yeah. So I was talking about CubeID, right? So in CubeID, it is like the Arduino ID platform, but here, as I told, you will be getting the picture of the board, the pinout configuration of the board. Here you can configure the pins and you can generate the code. So when you generate the code, like I have initialized I2C here in the pin configuration only. So it will initialize your I2C1 in your code automatically. You don't have to initialize it separately. That my PB or D15 and D13 are my I2C pins. I don't have to initialize that. I can just configure here and generate the code and it will automatically get added to the code. So basically that is an advantage if you work with CubeID part. So because EC students or triple E, like their main forte is on this circuit things or the devices. So for the coding part, this is the best platform, this is the best software. If they are not strong at their C and C++ coding, they can take help of this software and they can easily get in template and they can just add the printf statement or some functions run the code. That is the advantage of this. So like open source. This is open source. This is open source. You have to just log into your account. You have to create an ST account, give your email ID and password, and you can use it. So after configuration, this is the template. So this is the template. So here, this sensor is basically an I2C sensor because it has SDA and SCN pin. Okay. So that means I have to configure my I2C and UART communication because through USB cable I am communicating the data. So before that, this is the template we will be getting, and like private include. Can everyone see it? Yes. So in this private include is the part where we have to write our own code. This include main.h will be there. It will be automatically generated. But this private part, private includes, private variables, private defines, there, that part of the code, we have to write our extra codes like private define. If I want to give the access number or buffer size, that I can define it here in the private define. So students will know that, okay, variables I have to define in the variable part. This definitions I have to write it in the definition part. Includes, I have to write it in includes part. If they write here and there, it will show error, okay? But in Arduino IDE, you don't know where to write what. Students get confused. First, input initialization, this function, printf statements, final logging part, all these things comes. They get confused what to write after what. So here, they will give you a template. From there, you can just insert your codes. So this is an advantage of the data logger code. So this basically here, the first step will be come to the cube ID. There in cube ID, we have to prepare the data logger code, which will help you to collect the data of the sensor. Okay. So I have connected the board. I will just run this data logger code. So here, this is the console part where you can see there are 0 errors and 0 warnings. Then I can go to the debugging part where I am dumping the code inside the microcontroller. Disconnected. Right, guys. So it shows download verified successfully. Now I can open the console. So for opening the console, so can you see this console is being connected to the microcontroller, and I will just. So this continuous data are the Z values of this sensor. Okay, if I see the values will be changing. So the first value will be X, second value will be Y, and third value will be Z axis. So because it gives an 3-axis, it's a three axis sensor, a total 6 axis, but 3 for accelerometer and 3 for gyro. So XYZ value for gyro. So this is the XYZ values continues in a buffer size because in nano HAI, the data in the buffer size. If you give 0 buffer or 1 buffer size, you can't build a model in nano HAI. What is difference? Something and buffer size of 1 because buffer size is in a single line you will be having that many of data like x0, xy, y0, z0 till how many buffer size? Like I have given you a 256 buffer size. So that means in a single line there will be 256 into 3 values of x, y, z. So total 7 something values will be there in a single line. And then again from the starting it will have another line. So this is how we have to do our data logging part. This is for all the sensors. If you're building a classification model, if you're making a 2 raised to power n, you can change the total value of buffer size. Like if I'm putting n has 10, 10 2 raised to power 10, 1 0 4, I can put it and in single line I can print 1014 values. Okay, so this is how buffer size works. So this is fine. I have done the data logger code inside the microcontroller. Now I will.
So what is the actual output of the sensor?
This values ma'am, X, Y, Z
Now
values.
from here, which is going to the
This is basically like this we will be building a model. This output is just the variation of X axis, Y axis, and Z axis.
so is in terms of voltage, current, and how it is taking in the code.
Only
Directly.
the parameters of X, Y, Z.
So sensor itself is converted the
Yes, the values. It's an I2C sensor, so it gets your digital values and it provides here. If you're talking about voltage sensor or current sensor, if you attach it, then we can tune it according to the or current sensor, voltage sensor. We can display it in the serial line. But this is just the output of XYZ parameters of this sensor. Because like audio sensor. Audio sensor, you will be getting your analog values. Like if it's resolution of 8-bit, you will be getting 400 something values of audio sensor. So this is how like you will be getting 400 something in full one line 256 values or something like that. So that is audio sensor. But this is motion sensor. So we are getting in terms of XYZ. So you can see that negative values are also there. So the Z axis, which is going towards down, it shows the negative value. In sensor also, there is one small diagram, like Y goes on top, X goes this way, and Z is this way, like three axis. So my data logger part is completed. Now the major data collection is left. The data collection will be done inside my Nano AGI. So this is my Nano AGI software where I told you about anomaly detection, N-class classification, one-class classification, and extrapolation. So extrapolation is basically for prediction-based models. Like if you have temperature and humidity of 1 month or 2 months, you can predict kind of moisture or some kind of weather condition for another next month. So this kind of prediction models you can build with extrapolation. One-class classification is if you have only one signal but that signal is also an anomaly signal, like a bad signal. So that you can build with the one class classification. If you have n class classification, that means you can collect n number of signals and classify it. If I have female voice, male voice, child voice, some kind of birds noises, all these can be classified. And when you play it or when you record, like when you give it sound, it will classify as female voice, male voice, like this it will classify. Anomaly detection, it can detect anomalies in a machine, in a system. So anomaly like what is bad, what is good. So that kind of signal. So here we will be going for because because we are going to detect what is in this fan what is abnormal and what is normal signal. So I have we'll go to this thing. So here basically the target tells you about the board. You have to select the board. If you're using this microcontroller board or any other microcontroller board, you can just search for the microcontrollers present and you can select it. Now, The main thing is the sensor type. Can anyone tell me what is the sensor type of this sensor which we are going to use? I told you it gives three parameters for accelerometer and three parameters for gyroscope. So here we are using accelerometer parameters. So what will be the axis number? 3. 3 will be the axis number because it is giving you x, y, z values. Okay. If it is a light sensor, then what will be the parameter axis number? Light sensor. Only the lux value it is giving. So what will be the axis number? 1, I think. Because 1 will be the just the value of lux will be the axis number. If there is a temperature humidity sensor, so the axis number can be 2 because 1 for temperature, 1 for humidity. Okay. So here we have selected accelerometer and 3 axis. Okay. But if your sensor is not here, like it is not named here, you can always go for generic. Here in labs, generic is there. You can go there and you can give how many access number your sensor gives. You can go give there also. And there is one more in cross sectional. There is a multi-sensor part also. In this multi-sensor, you can connect 2, 3 sensors at a time and you can build the AI/ML model also. But like you are connecting temperature, humidity, light sensor, ultrasonic sensor. So that means 4 parameters are there. Okay. So 4 axes you can define and you can build your apps. Okay. Clear? So, so my searching second part is over. Okay. First part is over. Now I will move to the second step. So second step is to collect the regular signal. Fine. So how to collect the signals here? You can click on add signal. Now there are two options. One is from file, one is from serial USB. Serial USB will be your real-time data and some file will be your pre-defined data which you have already. Okay, or you are downloading from Google, you can use that. So now, for now, I'm using real-time data. So this is where you have to give the form. Give here how many number of lines you want to collect. Like here I can give for 50. Okay. For just demonstration purpose, I'll give 50. You can give 1,000 number of lines, 50, 500 number of lines. You can give as many number of lines you want to collect. Okay. And I have, this is my normal condition without any disturbance. So I will just start the process. Can you see there are three graphs x, y, z? So it is collecting the x values, y values, and z values, and the graph is being like the data are being collected. Fine. So now after the data collection is done, it will show you that 500 number of lines are completed, and you can confirm and you can continue import the data and all. So if you want to download these data also, you can download it from here. The files you can download it, and these files, this data will be directly in CSV file. You can directly download the CSV file. Now, my third step is abnormal data. So, same way from serial USB, I will give here 50 and I will be giving a yet a abnormal signal. I will just give a disturbance. Okay. Can you see the difference between the abnormal pattern and the normal pattern? So I'm giving a disturbance. Okay. This is creating a sound vibration or the external sound. So this is your normal data. Okay. So after two signals are being collected, if you are working with N-class classification, there will be one step lesser than this anomaly detection. In second step only, you have to collect all the signals. Here you have two separate signals, but there you can collect all the signals in one step only. So after this, my benchmark process. So benchmark process is where you, after collecting the data, you run the model. Okay. Based on your data collection, it will give you the accuracy. Can you see the score? This is the overall accuracy of the model which you have built. Okay. And it will distinguish between regular signal and abnormal signal. So the 0% is your abnormal and your blue line is called your abnormal data. So the output which you will be seeing at the next step, it will be in the form of similarity score. If it shows 100% similarity score, it is giving you as a normal data. If it's giving 0%, it is an abnormal data. Okay. Now these are the step of benchmark is basically it runs your model and gives you a balanced score, the overall score, and the libraries it has searched. Like it shows here, 75 libraries are being searched. They have, like they must have searched for RF model, SVM model, all these models. But according to my model, what is the best model, they will be giving it. Okay. And the yes, this performance measure you will get back to accuracy. It is an A model. Apart from this A performance measure, you have to validate the results. Um, because in the normal ML models, the other measures are there. Cross variable, it's any unique one. This is only parameter you no. Here, this is the overall score. In the next step, you can find your median, standard deviation, means, everything. And also you can get the confusion matrix also. So, like, uh, like if you are writing a paper and you want the different, like the comparison between all the models. Okay. So in the list, there will be your model and other models also, but the accuracy score will be less. So you can compare their confusion matrix with your model. Okay, that is, I will show you in the next step. And this main thing, 20 iterations, is basically what, how much you have to train your model. So I'm getting 20, you have to add 10 more, like 30 cycles you have to train and train the final output. Like to get the output, you have to train the model. So this is the use of iteration. So here, these are the models. So the model which I built it is a ZSM model. So you can see the crown one also. So for the comparison map, you can go for IPCA. If you go down, the accuracy will be lesser. So you can, if you go MML, all these models will be there. Okay. If you go for N-class classification, you can see RF models. So there will be different models present for different classes. Like for extrapolation, there will be different ML models. For this, there are different ML models. So like this. So now you were talking about the report. So report you can download from here. Like you can just click on here and see the confusion matrix. How many signals you collected? What is the matrix? The performance, the RAM, flash, median, average, minimum, standard deviation, all things are there. Okay. So you can download this also and you can compare it.
So what is the size it has taken for training and testing?
This is that part is the backend part. They have set up the software. So it basically the training and testing part in anomaly detection will be next step. The serial emulator part. First, we have to train it. Like basically the learning part will happen, and then we can see the detection
You
part.
have not yet trained them.
No. Now the training part will be
Given some iterations.
iterations is based on your model learning part. It is like it is giving you the iteration. So when I train my model, I have to add 10 more and give the training cycle. This is little different from the actual ML model which you are building. If you're not using this nano edge AI now, you can always go for your machine learning Google Colab. You can build your machine learning. There we can find the loss, accuracy, validation, everything, all these things. And then that is a separate part. But here in this nano edge AI, if you are going for N-class classification, you don't have to train the model. You can just build the benchmark, and second step in the emulator, you can just see the output that is there. But in anomaly, you have to first train it because we have two signals. That's why we have to train it in the anomaly part. So the output part, you can check it in serial emulator. So can you see this is the learning part, start learning. So now the learning will be done on the basis of my normal signal. So I will give here 20 is my average because 20 iterations I got. Here I will give 30. So my minimum mark is 30, 20 only, but we'll learn till 30. If I give 50, 60, it will be overfitted. If I give 10, it will not train. So I will just start here. So slowly it will learn the model. Like it is learning the normal condition. Fine? So my learning is completed. Now I can go to the detection part. So I told you we can check the output has similarity score. So when the normal data will be running, it will show you 100% similarity score. When it is an abnormal data, when there is a vibration or a sound, then it will show 0%. So I will just start it. Now there is no disturbance. It is showing 100%. Fine. It is showing as 0%. That means what I have built a detection model and the detection model is being developed. Okay. Through this nano HAI. Now I can say same thing I can do with my machine learning model also, like the pre-trained one, like the I can build it in Jupyter notebook level. So basically, what is the main difference when you do the actual ML model and you can see many mistakes? This is basically this can be a lesser like training part and all. This AI model you can build it in 1 hour also. Like it reduces the time, and for comparison for different kind of like exploring things, what are models and so you can work with this one. But if you want other than these models, you can always go for your own machine learning models. But which one will be accurate? Accurate. I think this will be more accurate. It takes by default itself. Yes, that is we are giving the data, and you will see that we will never get an accuracy of 99.9% there. Here it was 98 point something, but there we will always be stuck in 96, 95, or 85 also. So that is the thing, but this is an automated tool, so it gives you more accuracy. So that's why the standard accuracy range is also above 95%. If your model is not good, like not above 95%, you have to again collect the data. So that is the main this thing challenge over here. If your model is not coming above 95, then you have to again go back, collect the data, and again build the model. So this is the difference. So now we have built the model here. Okay. Now the last step is deployment step, where I can compile the library and I can download it. Okay. So after I have downloaded the library, yeah. So after I have downloaded the library from that Nano HAI, I will get some certain libraries. Like, can everyone see this NEAI folder? Here, inside that NEI folder, there is INC, there is lib folder. So these two folders, Nano HAI and libnia.a file, we got from the machine learning model which we have built. Okay. So in the folder name of Nano HAI NEI folder, you will just copy paste this two files and give the path so that your that ML model is linked with this cube ID and you can write the deployment code and run the code inside this microcontroller. So it will give you same model, the 100% and 0%, it will show here also. Okay. So I have attached this Nano HAI header file also here. Can you see this number learn? That is your training cycle. So I have given here my iteration was 20. So I have given here as 30. Okay. And similarity score, I have defined it. Now, the part where we have to initialize the Nano HAI, this is like in a NAI state error. So it is anomaly detection, it is connecting and it will show you the values. If your Nano HAI is not properly linked up, it will show application initialization not done. So like that, you can define your buffer set, define your datas, then training part, we can define it with test statement, and the final output has similarity score is. So your final output will be your similarity score is. So same way, we will be tapping it, it will show 15%, 15% or 0%, 1%, 2%, that is your abnormal data. And 100% means your normal data. So I will just run this data, run this code. Oh, like, is it fun? Like, are you understanding the concept and the process? Any doubts? Uh, fine. So, no doubts, right?
Yes.
Is it clear, everyone?
So, change here, chat. You are like, he's not as good now. You think as yeah, I'll get him from Congo. I give you should tell me what happens when it's been here. Why don't you tell? So you engage almost like
Sometimes giving one external vibrate that it is informatic is moving 1 to 2% like this. Yes. So the same model which we built it in Nano HI Studio, it is being dumped inside this microcontroller board. So now you can remove this USB cable, you can give a external power supply, like with the battery or a power bank, and you can always make it as a standalone model. So you connect the sensor and the board to the AC or fan, and you can take the abnormal and normal vibration signals. Okay. So is it clear? Yes. So now, now I would like to show some videos which is done or created by this ST boards only for this coffee machine. If the coffee is done based on the vibration of the coffee machine, will give you the this thing, the correct data. So this is the and sensor is on the top of the jar. So the machine is learning the behavior. So he has triggered the alarm that if my coffee is prepared, the sound will be played. So he's removing the sensor. This is the same sensor which is used here, and your coffee is prepared. So this is like a training of your coffee machines and tea machines, all these things. This is very small application. This one more, the same way, predictive maintenance of fans and all. So like they have placed the prototype. So like they have placed the prototype. Same console, same UI they have used. So this prediction has no leakage, and if there is a leakage, if it's valid, like anomaly for leakage, and it was a supply search point. Clear? Did you get the how we can implement these small parts in our real life applications also? We can build our own AI/ML models I had one more video to show. This is based on Vision AI. Like we can use camera modules. There is another board which is based on M7 ARM Cortex M7 processor. So that is also there. And you can use like same pose estimation, behaviors of students, all these estimation can be done with the camera and the Vision AI application. So for this, you have to build your own AI ML model, like using neural networks, some kind of YOLO models, all these models you can make it. Yes, yeah, deep learning, neural net. Create your own website really easy. Like these, this is the hand landmark detection. So here, the main thing will be instead of sensor, we'll be using a camera monitor, but we'll be dumping the model inside the micro. It's all based on deep learning, YOLO model, hard cascade, all these things. So one more I was talking about.
Well, before playing with something through the defense, I knew that by channel. Okay. But it's also very after the
So I was talking about Cube.ai part. So this Cube.ai can be done with the manual part in CubeID. In CubeID only you can install the package of Cube.ai. But there is one more new online platform. Like this is online. This is not in software you have to download or something. This is fully online. You can go to this STHAI Developer Cloud and optimize. You can quantize your model, ML models which you have built it. Okay, but that model should be in form of .tflight extension, Keras extension, ONX extension. Okay, so you can just optimize it. Like this is the process basically. These models will be working. They can come to the developer cloud where you can optimize it, where you can quantize it, where you can um, optimize your RAM size, inference time, all these things, and you can dump it inside the hardware. For that, you will get an optimized model, your CubeID project. Like there, have to write the own code for the deployment. But here, when your model is prepared, converted into C++ library, you can directly download the code and just copy paste in CubeID, run it. That is the part why we have introduced this STHAI Developer Cloud. So this is fully like AI based. You can develop all kind of AI models, all kind of deep learning, neural networks. If your model is more than like 256 size of model files is there, you can optimize it and convert it inside the hardware also. So Python sequence to automatically conversion. Yes, with this tool you can do it or Cube.ai, Cube.ai part. But this is an online platform. There you can do it manually. Like you have to install the package, then you can convert it. So this is the AI, how you can develop your own AI models, AI ML solutions with these microcontroller boards. And there are so many varieties of microcontroller boards available. AI models, you can work on different projects, mini project. So instead of using Arduino Raspberry Pi, you can like students can work on this and uh, you can also like work on different microcontrollers and create new projects as well. So this was from my side. I hope it was a good session. And I'm open for feedbacks. Any questions if you have, please you can ask.
Yeah, so some other comments related to AI subjects. AML is something you about this. It's three comments are related to IoT and AI.
Yes, yes.
So you can provide them.
We have last year only week only I had a meeting with ma'am, HOD ma'am, AIML. Yeah. We have already established labs in AIML, PS department, Triple E is there, some other departments, EC is there. Departments are there. Oh, machine learning departments. So you just talk with them. So if investors let them go with the machine learning. So, like for mechanical also, we have different solutions. We have FPGA, we have robotics, we are working with robotics. So we have a separate department. Yes. So robotics is there, FPGA. In this also for EC, Triple E, for instrumentation department, they can work with vision boards. Like they should, their main focus will be on the board part, creating a AI model and dumping inside the model part. But when we go to our AIML department or a CS department, our main focus will be on developing a model. So we'll not focus that much on the microcontroller part because it is not related to their syllabus. So according to the departments, we change the requirements and all. So scope is the yes, so it was very good. Like students, like if they get the training now, they will be very interested and they will be building their own solutions because we give training to some colleges and all. They will be contacting us that ma'am, this is our doubt, we are taking this project, this, that. So we will be giving them so it's not that much open for yes, yes. Solution for industrial application. Yes. And you know, it's just for the basic project. So if you want to model something on IoT and all, say right to like and board for creating IoT based industrial application. It's not a logic center. You have to go with it because we are expecting many things for AI and IoT. Yes. Just have to come. IoT, nothing has happened so far. It's just controlling the fan from somewhere. So, like that. We have many other requirements already, like agricultural or health applications. Lot of scope is there. Yes. Agriculture is very, even if it is a bit of water, we want to pour some water. See, that sort of application not at even many other applications are also there. So that we have to take it up through the industries. And so like simple water purification with pH sensors you can integrate with this or any other IoT board or some other boards you can go for higher end boards also and you can build an AI module purification, agriculture based irrigation system, all these things can be built with this. So thank you so much for your time and patience. I hope it was an interactive session and thank you so much for this opportunity and uh, you can explore more and if you have any doubts or any question, any support you require, you can always contact us at our support at digitotech.com and you can always mail there whatever you're working on projects and all. Thanks.
Thank you very much, Mark. Thanks a lot for your informative session. We learned how to gather this from gathering data to deployment to the chips and how to build an AI model using a different software where you can do projects as well as you can also publish papers to these. Learning was really good. Thanks a lot. I request Dr. Joseph sir to present a moment of appreciation. Thank you all. Tomorrow we'll be having a session in area of itself at 10 minutes.
Actually, I arrange students and we can't. We have physics people still be attending.
Time is really time. Sir, how? Sorry, it was your standing.
Yeah, not
It's your
stop. It's
product,
really
no?
beautiful.
It's wonderful. So we are not,
Take group photo. We all of it.
it's not your someone's product. It's your
Yes,
product. So we can,
We take one group photo.
yes.
okay. Come on.
It's not stopped. It's really good.
All of you come tomorrow for 1, 2, 3, 4, 5. Yours.
Tomorrow, one director of one cyber in a company, she's coming. Please, all of you be here. Startup company.
Only teacher they get you bring your student, 10 students. Then spread the news to